Right, when we solve these inequalities, it's not a lot different than when we solve equalities. The only difference is first we have to look here at this denominator that has a variable in it, and we realize that x cannot equal 2, because if x equals 2, we have a denominator that equals 0. So we make a little note of that. Okay, next up, we look at this equation now, because we kind of treat it like an equation, and we want to get rid of the denominators, basically. So one of the things we want to do, I'm going to move this out of my way so I have room to write. Okay, we want to multiply everything by 3, because that's going to get rid of the first denominator. We want to multiply by x minus 2 to get rid of the second denominator, and we want to multiply by 4. So if I rewrite this problem, x over 3 minus 1 over x minus 2 equals x plus 1 over 4. And then I put this LCM in, so times 3 x minus 2 times 4 times 3 x minus 2 times 4 times 3 times x minus 2 times 4. Now you can see how things will cancel out. The 3's cancel, the x minus 2's cancel, and the 4's cancel. So now we don't have any denominators. We just have to multiply what's left. So this is x times x minus 2. So we have to distribute there. And then multiply the whole thing by 4. So that would be x squared minus 2x. Multiplying by 4, we have 4x squared minus 8x. Right here, it's negative 1 times 3 times 4, which is negative 12. And on the right, we have 3 times x, and 3 times 1, so that's 3x plus 3. And then we have to multiply it by x minus 2. We can box that, but by now we should be getting pretty good at saying 3x squared plus 3x minus 6x minus 6. Okay, next line we're going to subtract 3x from both sides. We're going to subtract 3x, which will give us negative 11x, and then add 6x, so that's negative 5x. And then we're going to add 6. At this point, we can easily factor this. We can get x times x, negative 6, positive 1. And then when we solve, we get x equals 6 and x equals 1, or excuse me, negative 1. These are the other domain restrictions in this inequality. So we're going to grab our white pen, because we can't erase a picture, but we're pretending that we're erasing here. We want to erase or break this line at 2. We want to break it at 6. And we want to break it at negative 1. So now we have this pink region. We have this blue region. We have a yellow region. And we have a purple piece of this number line. And we want to test a number on each line, on each segment. So if I take negative 2, for example, negative 2 over 3 minus 1 over negative 4, because negative 2 minus 2 is negative 4, is that less than negative 2 plus 1 is negative 1 over 4? Well, these cancel. So we have negative 0.67 plus 0.25. Is that going to be less than negative 0.25? Well, if we use our calculator, grab mine here, my bag. So negative 2/3 plus 0.25 is negative 0.41. That is less than negative 0.25. So we want to keep that piece. Next, I'm just going to erase because I don't want to have to move my screen around too much. We're going to test a number on the blue piece, which 0 is a great one to check because it's on the blue. 0 over 3 minus 1 over negative 2 is that less than 1 over 4? This gives us 1/2 because the 0 cancels. Is 1/2 less than 1/4? It is not. Next, we check a piece on the yellow segment, like 4. 4 over 3 minus 1 over 2, is that less than 5 over 4? Well, 4 divided by 3 minus 1/2 is roughly 0.83. Is that less than 1.25? Yes. So we want to keep that piece. And finally, we test the purple part. Pick a number on the purple part, like 8. So I'm going to grab my purple just so I can keep track of which part I'm on. 8 over 3 minus 1 over 6. 8 minus 2 is 6. Is that less than 9 over 4? Well, 8 over 3 minus 1 over 6 is 2.5. Is that less than 9 over 4? It is not. So since it is not, we throw that piece away. Now we just need to name the pink piece and the yellow piece for our solution. The pink piece, the first name is negative infinity. So we call it negative infinity, comma negative 1. That's the last name. First name, last name. The yellow piece, the first name is 2, the last name is 6. 2, comma 6. And that's our answer. And that's all there is to inequalities with rational expressions.